Here, that was our last break, so we're in the home stretch here. So basically what I'm doing in this presentation, what we're going to be doing here in this particular presentation is I'm going to look at some actual fields that we had where sensors were in this year, and we're just looking at some of the anomalies we saw, some of the interesting things that we could learn from actual fields where actual crops are being serviced by dealers here during the 2024 season. So something I want to start out here with saying is we always tell a customer when we bring them on board that every field is different, but I want to add something to that. Even within that field, if you've been using that same field with the sensor for 10 years, within that field, every season itself is different. So something I could bring up here is in this past year across a lot of the US, we had some very wet springs. And you'd think that would lead to an easy season, but it doesn't always do that because then those wet springs were followed by hot, dry spells in July and August. And that can make managing water even more difficult after you've had a very wet spring. We're going to look at examples here where a dealer and grower could be doing everything perfect, and then Mother Nature comes in. We know that crops don't like hail, and they definitely don't like hurricanes, as we unfortunately learned in the South this year. So something I want to mention here and just think about this here as we go through these examples. I say in the slide that people here farm different parts of the country, but really looking out at the room, we're farming different parts of the world. We have people from Canada, Latin America, Australia, New Zealand, South Africa, and of course, all over the US here. And even though geographically this field might be somewhere that is thousands of miles from you, the lesson we might learn from a field that we look at could still apply to your own farm management. So I just took a slide here from my own personal CropX account, just giving an idea of when I zoom in on my map view for the US, these are all the places I could be looking at any time. So if I go on my overview page, you can see how diverse the landscape is that I'd be looking at. And with that, we're going to move on to our first example. This is just the profile view for the example during the course of the entire growing season. And there's a few things I want to talk about this field as we get into it. So what do I know about this particular field? Just some background here. This is corn. It was planted in late April with a probe installation that came about 1 month later in late May. This particular field's in the Midwestern United States. And something I want to point out here is that the weather patterns in spring 2024 in this particular area were very wet. How wet? Well, here is our view of the agenda. And I could even go, but this is looking at May 2024, but if I went back to April, it'd be just as wet. And we could even see where our probe installation is noted right there. So you could see everything that happened since planting till probe installation. And there's a lot of rain, and plenty of those rainfall events that are plotted there are in excess of 1 inch. Now, that weather pattern didn't just end in May, it continued into June. Between May and June, I added up the totals here. This field had something in the total of about 15 inches of rainfall. In 2 months' time, that's a lot of rain. So let's ask a few questions here. What do you think this heavy early season rainfall is going to do to the field? Well, first off, on the good side, we're going to have very accurate set points. So if you go ahead and let CropX decide, you're going to end up with set points that are very accurate because that rainfall is going to allow us to find a full point. Now, unfortunately, on the bad side, it's going to impact how the roots develop. In this case, you can realistically expect that all that rainfall in your first few months after planting is probably going to stunt the root growth. You're probably also, unfortunately, going to have some leaching of nutrients here. And you're also likely going to have some disease risk because, again, you have a lot of wetness here and a lot of moisture in that soil and on the leaves. So here's that profile again for this particular crop. And right now, we're just looking in at the first month or two here. And you can see all those little peaks there. Each of those peaks, not a single one of these events here is an irrigation. Every single event there is a rainfall, and every peak you can see is going to be a separate rainfall there. You see that there is plenty of wetting events here, and this field never hits refill during these points. Now we're going to go ahead and zoom in looking at the moisture graph here. Now I actually turned off the bottom sensor here when taking the screenshot because all we could see is just basically a straight line across. But something I want to point out here is this is a 4-inch offset. And even with this 4-inch offset, You see any activity on the second depth? That second depth is at 12 inches. Do we see any activity there? We're not really seeing drawdown there. Almost all that activity's happening above that 12-inch mark. So you see a lot of movement on the 4-inch graph. So again, we don't see that root activity even with the offset. And with that wet field, we can see that the root growth was stunted because we would normally expect to see a lot of more action there on that middle depth. And this also, I'd say, may be a case where you consider a root zone set point, at least early on in the season. But also, I want to point out that this is a case where, because we have that sensor in the field, we actually know where those roots are. If someone's trying to make water decisions on this field and they don't have a sensor, they might not realize how stunted that their roots are, and they can end up making a grave error that can end up costing them yield. So we always want to have data. So I know there's a question at during one of the previous sessions about using satellite data. Satellite's not going to know root depth. This is where you have to have an actual probe to truth test the soil. So now we're going to fast forward on the same field. Now we're looking at July into August. And I just highlighted here where we do see that eventually roots did emerge. They were stunted, but that is July 27th here. We could see we finally get some root growth here on the 12-inch mark. And go from that point forward, we actually see some healthy water usage at that depth. So now we're looking again at our agenda on this field. And the reason that happened is rain slowed down very heavily in July. On July 3rd, we had a significant rain event, and we didn't really have a notable rain event that got above 1/4 of an inch until exactly 4 weeks later on July 31st. Yes, you might see some agenda points there where we do have some rainfall, but if you actually look at the amounts, it's often just hundredths of an inch. Not really something that's going to refill a profile there. And here we can go ahead and see how that, the same time span as the last moisture graph, this is how the profile sum looked. You could see that there was some healthy water usage here, and there finally was an irrigation that was done in the middle of July. And that irrigation was, you could see, is well-timed. It's right when we hit refill. And then another thing I'd like to point out here is while we did hit refill there in late July, they held off a little bit on that irrigation because they saw heavy rain. And on July 31st, we had about 1.5 inches of rainfall here, and we could see that did a good job getting that profile filled up again. So using the probe here, they were able to catch up on root growth, use the water in the profile, and then save on some irrigations. And then going forward, some rainfall came again in early August, and there's some irrigation activity there as we get deeper into August. You really see how they used the probe and recovered from what could have been a troublesome event here with the way the roots had stunted growth. Yes. Yep, that's exactly, and that's one of the neat things we have on our, if you look at our profile sum graph, we basically have that black bar, everything before that has actually occurred, but then we have that gray bar that goes out about 5 days. So as this person's getting into refill, they're looking ahead at their weather forecast and they're saying, oh, in 3 days, I'm expecting to get this amount of rain. And that's a case where we're using a weather forecast. Weather forecasts aren't 100%. So if you don't catch that rain, you're definitely going to want to irrigate. But you can make that decision as a dealer to say, hey, I know about our chances of catching this rain. Let's hold off to see if we get it before we make that go decision on irrigation. And by holding off on that particular irrigation, they captured a rain, and even that rainfall came close to filling the profile, but didn't. So they had the right amount there to capture the entirety of that rain. So again, this is just that full season activity here on example 1. Some difficult spring rains and a drought in the middle of the summer, but they still finished out pretty strong. So now we're going to move on to example 2. This is corn planted in mid-May. Probe installation came in late June, and the field is located in the Central Plains here. And this one came to our attention because the customer reached out to us wondering why their water usage was so low during some hot and dry days in the middle of July. And I took a screenshot here. They reached out to us basically in late July here, and they're looking at this period from July 22nd through the 27th. And we see during days where the temperature was in the low to mid 90s with a lot of sun, they're only seeing 0.35 inches of water use. So that's less than 1/10 of an inch per day, which is much lower than it should be. So what are some ideas here? Why do we think that maybe this happened in example 2? No? Well, we're going to find our answer here. So here's our moisture graph here, and here's the depths we're looking at. So we see here that this one had stunted root growth, a lot like example 1. There's something different in how the water was managed here going up to it. You could see that 2-inch and the 6-inch sensor are both reading water usage. That 10-inch, this period here of about a week, that maybe moved 0.5% volumetric water content. That's not a lot of uptake there. So that basically tells us that our roots are not really doing anything at 10 inches or below. So we agree the roots did not reach 10 inches. Why did that happen? Well, here's rainfall. They did have a very wet rain season in the beginning, like example 1. But here's where they differed from example 1. Look at all those irrigations. If you space those apart, that's basically almost every 72 hours. It feels like they're giving an irrigation when they should not be doing so. And there was then an irrigation there, which even worse is followed by rain. They're looking at their forecast. They should definitely not be irrigating when you have rainfall coming in there. So the auto set points are great. Remember to accurately account for soil wetness at install. In this example, they likely put in optimal there when they were much closer to full. This would actually be a great use case for doing the let crop decide. Had they done the let crop decide, or they put it in at full, they would have had set points that were accurate here, and thus they would know that they had a lot more room to refill. In this case, they get to the middle of the optimal zone, which really is near their full, and they're thinking, oh, I've got to irrigate. So we did take a look in here, and we actually went in and manually adjusted their set points there in late July to help fix for that. But something I want to point out here is that the unnecessary irrigation didn't just waste water here. They were flushing nutrients down. They're wasting energy because it costs money to turn that pivot. And of course, they're harming their crop's development here. As we see, there's not a lot of water usage here during days in July when it really should just be pulling water out of the roots. So I just want to highlight again that in both cases, the weather patterns were similar here, but the difference is in one case, they held off on the irrigation, trusted the probe here, and let the roots catch up. So yes, you had stunted root growth, but they had developed and they'd caught up by the time the crop hit the reproductive stages. And it really paid off here for example 1. Whereas example 2, they probably had harmed their yield there by overwatering throughout that period. So it's a good example here of people think we have a lot of dealers here. Maybe they got customers in areas where they're not worried about how much water's in their water table. Well, you still don't want to overwater, even if your water's cheap, because that's just flushing yield down the drain. Example 3, we're going to look at another one here. This is corn planted in early May. Probe installation was 1 month later in June. This particular field's in the upper plains. And I just want to show an example of how the roots that were well developed use the entirety of a profile here. Again, common story in 2024. And this is how we talk about how every season's different. It was very wet in May and June. And I'm just showing you the agenda here where we have plenty of rainfall. A lot of these rain events are going to be in excess of 1 inch. So the profile had a lot of moisture in there to start the year. But then drought took hold. I just using the examples here of August and September here, and we don't see a lot of rain events here. And a lot of these rain events that are here, we're maybe looking at 100, 200, 300ths of an inch. It's not a lot of water usage there. So, and also July was the same pattern. So I want to show what our dealer did handling this one. So here's August 1st through September 15th, their water management. I think they're irrigating a little bit too much at the front here, but then they started trusting the probe here after they did that. So we could see some irrigations there. I think I could skip some of those irrigations on the 2nd, 5th, and 10th and like it more into refill before doing it. But after that event there was a rain event on the 13th and 14th. And what our dealer did after that particular event of rainfall is they held off. And here's what that looked like. Once they held off there, they allowed the crop to go ahead and pull water there and gave it a long stretch there of just healthily drawing water through the roots there. And then they'd made an irrigation decision later on. maybe a little bit too early on the other irrigation decision, but they also didn't fill it all the way to full. So I can't say and they also didn't lose anything if there was a rainfall that followed. So I can't say it was a bad one. But I'd say that we could have saved some irrigations here, but in the end, the roots still did well. And we could see here throughout the entire 26-inch profile, there's healthy water usage. Yes, we see more up top, but 26-inch, even though you see less water usage there, that's typical. It's still using water there, which tells us that the roots did develop down there, even if they started off a little bit slow.
Hey, Ben, we have a question.
Sure.
Going back to example 2, could one of the issues have been the very late install and root damage when drilling the hole and installing the sensor?
Great question. And I'd say, yes, that could have been a contributing factor there. We always tell you to try, we want to get the planting and the installation a little bit earlier there because you're going to get better data there. And if you're installing and it's almost the 4th of July, I think this installation was probably June 29th, June 30th. That's a little bit late in the install season here. We'd like to have had that earlier in there. So that is a possibility as well. Good question. Good question. So now we're going to move on to example 4. And this is just to show you sometimes events are completely out of our control here. This was a cotton plant that came out in late March with a probe installed in mid-April. And this field is along the Gulf Coast here. So it's located in the south. Here's our May to June profile summary. See healthy root development, good water usage, some rainfall and irrigation mixed in there. So we saw early season allowed the roots to develop and draw down the water. There was a very well-timed rainfall in late May that helped fill the profile nicely and allowed a skipping of a major irrigation. And then we see in mid-June, there's a well-timed irrigation that got us into the mid-optimal range. You can see that event here where we had this was our well-timed rain. It stayed up. There was some other rainfall there. It drew down. We had a irrigation here, drew down, irrigated again, and then is hopefully drawing down again. So we're now here at the end of June. What happens when we get to early July? So what do you think happened here? And I'm using the ruler tool here to highlight this, but this is a 3-inch increase in 4 hours. So I really zoomed in here. This is 4 hours that I've highlighted here. What do you think gave us that 3 inches of water in the profile? Does anyone want to take a guess here? Come on, have fun. Let's make a guess here. Bingo. Hurricane Beryl. And this is actually this image here is a weather satellite image of Hurricane Beryl when it was south of Hispaniola and north of South America, back when it was a Category 5. Now, it might have been a Category 1 at landfall, but remember, hurricane category is not about how much moisture it has. It's about the wind speed. So yes, it may have degraded from Cat 5 to Cat 1 as it hit a little bit cooler waters in the Gulf because early July, the Gulf hadn't heated up to what it did later in the season, but it still maintained all that moisture. And just look at this. I looked at the DTN weather data that we have on the agenda, and in fact, 6 inches of rainfall had fallen on this field here within just that couple-hour period. Of course, the field could only increase by 3 inches because it was completely full and saturated at 3, even though 6 inches fell upon it. Now, of course, the nutrition feature logged a leaching event here, and this was a little bit of a sad case here because the dealer in this case told me that he was on pace for a record yield on this field until the hurricane came. And unfortunately, while it didn't wipe out his crop, it negatively impacted yield. So I just want to show here, a dealer could do everything right, and sometimes Mother Nature just has a vote that we don't get to veto here. So I just want to show another example here of a permanent installation. And this is just one where I like to nerd out a little bit. And we might actually see more cases like this because the reality is with the improved battery life on our Vertex probe, a permanent installation is a lot more practical. I think realistically, with 12-hour transmission intervals, you can probably realistically go 400 to 450 days between swapping out battery there. And you don't have to take the probe out of the field. You just unscrew the top, take the battery out, put a charged one in, and the battery you removed, if you recharge that, that could be your spare battery. So permanent installation might be something we see more of here. This was a case where a field was being monitored for soil temperature during the off season, because they wanted to go ahead and look at thawing and freezing here. The field in this example is in the Great Lakes region. Sensor was installed in May for growing turf. And actually this field is still, this sensor I believe is still active in the field right now. So here's our profile sum for it. We could see they're managing the water there during the season. Obviously they stop managing it as we get into the fall. And I just want to highlight something here in January, what happens here. Volumetric water content completely collapses. And as expected here on the profile sum. And we can see that here on the 4-inch, 12-inch, and it's starting to happen on the 26-inch. What do you think we're seeing here? I heard the answer there. What we're seeing here is we're seeing the water turn from liquid into ice crystals because it impacts how it reads. CropX sensor will read that water very well when it's in liquid form. When it's ice crystals, we're not going to read that water. And here's the temperature graph here. And we could see I just drew a line there on this temperature graph looking at the freezing point there, 32 Fahrenheit, 0 Celsius for the international group in here. And you can see it happens first just before New Year's. We see on the top sensor, it hits freezing. But I'm going to go back here. We don't see it really drop off until July 2nd or 3rd. Why do you think is there a delay between the temperature hitting freezing and the VWC dropping? I know I'm asking a science question here. Yep, latent energy. That's what we're talking about here. If you remember from physics, we learned about latent energy. There's still some heat energy in that water that has to leave as it gets colder. So it takes time for it to freeze. It doesn't just magically freeze at 32 degrees. It's got to bleed off that heat energy. So you can see here, we hit 32 degrees, get below it, but it takes about a 2 or 3 day lag time before it completely materializes into ice here. So permanent installation here, just as we saw that freezing of water, when we fast forward maybe a month or two from now, and that temperature gets above freezing, we're going to see the thawing just as we saw the freezing there. And likewise, it's probably going to be some latent, it's going to be some energy needed to go ahead and melt that ice into water. So there will probably be a couple day lag time between the temperature change and the state change of the water. This data is actually very useful for a lot of universities and research projects that use this information, and it can help them determine ideal planting dates and just see what's happening in their soil year round. So the next example here is going to be talking about why probe location within the field matters. And this is one I think Nick Stahl tipped a little bit what we're going to be seeing here. So we have a field managed here by a grower in the Midwest. And I want to point out that this was done by a grower because I don't think we would run into this issue if we had a dealer who took care and looked at the field. So this was corn planted in May with a sensor installed in July. For one, I'd say I think that sensor install probably is too late. It should have been done earlier. But our grower reaches out to us late in the season asking why they're not seeing any root uptake on their graph. And they're also wondering why they don't see much irrigation after rainfalls and irrigation. So here's the graph. That profile sums next to no movement. It's a flat line across here. And if I look at the soil moisture graph, I'm seeing the same story. It's just a straight line, all 3 depths. So this is one where Nick Stahl discovered what was happening here. So what do you think might be a reason why we're not seeing water usage? This is an example just showing the field, the picture today of it. But what do you think might have happened in the past that could influence why we're not seeing water usage here? Filtration. Oh man, you're getting all the points here right now. Compaction. So here's what happens. Nick Stahl looks at this case. He puts in the GPS location. And what does he do? He goes on Google Earth and solves that mystery. What's right there on the 2011 picture here? There's a road literally right where the sensor is. And I went in myself to look at this after the fact when I'm preparing these slides. And the historical imagery on this field went back to 1994. So we see that road was there from probably decades even before then. Yes, we can only go back to 94, but I'm sure that road was pre-existing there for a while. So some point between 2011 and 2024, they went ahead and they removed that road, but the damage had already been done there. clearly. So we always talk whenever we do our preseason talks, which I'm sure we'll be doing in the next few months. We talk about picking an installation location. We always use the phrase field history matters. This is what we're talking about when we say that field history matters. It's important to know what's been in that field over the years and identifying trouble spots. Because the decades of presence of this road definitely compacted the soil. If you go back to our agronomy day 2 days ago, we saw a picture of what that compaction looks like on the surface. And we can definitely see on the bottom what it's doing is it's impeding the percolation of the water and it's compacting the soil so that there's no gaps for the roots to develop there in the first place. So just always make sure, especially when it's a new field and you've never worked in it before, make sure the installation location is representative of the field. And I just want to highlight that this is a great example where having a dealer perform the installations and managing the probe can be helpful. I have a feeling if this wasn't a do-it-yourself case, we would have had a much better outcome here. And just show even beyond the Google Earth tool, there's other tools here in the CropX app. So right here, if you go into the field data tab on the web app, I love doing this. If you scroll down, you'll find our productivity map. What that productivity map is basically summing together years worth of NDVI data to tell you where the most and least productive parts of your field are. Now, what can we see here with this probe location? They installed it on the historically least productive area of their field. It is not at all representative of the rest of their field. It would not, even if without that road and that satellite data, we could look at this information, which is inside the CropX app, and we could tell you that this would be a very bad spot to install the probe. And then now let's look at the during season NDVI data. So I just took an NDVI image from around the time the customer's reaching out to us. And even in season, what is the single weakest spot of the field where the probe is? And likely due to the fact that there was extreme compaction in that location. So the last example I have here, I just want to demonstrate and show you what a leaching event could look like here at the different probe depths. So this was corn planted in May in the Central Plains. Sensor installed 4 weeks later in June. Good time to install it. And the field had some sand towards the top of the soil, and the crop was harvested in October. Event this is the full season here. I'd say they did a good job managing their water. And what I'm going to highlight here is from June 30th to July 1st, there was a 2-day rain event here. So again, this field is going to be an example of leaching here, but it's not going to necessarily be the fault of the dealer here. Dealer's doing everything right here, and this was just a heavy rain. So here's our ruler tool over this 2-day period. We added 1.13 inches of water infiltrating the soil during that 2-day event. And but you could see here, the profile already been pushed to the limit on day 1 of that event, and it just kept raining here. And we'll go ahead and look at the DTN data here. So we could see that that is roughly 3¼ inches of rain in a 48-hour period. Pretty substantial rain here. And again, we know from the previous slide, on day 1 of that event, June 30th, it had hit capacity. So what do we think this did to the nutrients in the soil? Well, we saw leaching show up on that second day. So the leaching event starts here with that spike in the EC from the nutrients on top of coming in from above. And then we see as it continues, those nutrients come in and they're washed right out there through the soil. So I'm actually just looking at the middle depths here on this particular sensor, but you can really just see where that leaching event occurred. So again, sometimes nature has a mind of its own. This wasn't due to any error by the grower or dealer. We could see even after that event, they recovered well and managed their profile pretty well with some good decisions there. So what are the key takeaways from these examples we've looked at? I showed 7 of them. I really just want to highlight that each is different. On any of these examples we looked at, we saw some weather anomalies with those very wet springs. You might have a dry spring next year, so you might not have an issue with stunted root growth. You might actually have to irrigate earlier in your season sometimes. And while we love rain, it doesn't always fall when we want it or when we need it to. It's like an old saying in baseball, don't tell me what you hit, tell me when you hit. That's what rain is. It's all about the rain can sometimes come in with a clutch play for us. So I always will say, stay on top of your profile graphs. Trusting the sensor is a good idea here. As we saw in example 2, one, they made a mistake on their set points, and two, they didn't trust the sensor. So all those unnecessary irrigations compounded, and the stunted root growth never recovered on that case. I'd say make use of some of the advanced tools we have here. Satellite is a great tool to have in your back pocket, especially if you're scouting a field, trying to figure out what you might need to do there. If we'll use satellite imagery to figure out where to plant, or where to install your probe and where you might want to manage. Use nutrition features to go ahead and take a look there, stay on top of that. Disease features, great. And also, if you're in our graphs, go ahead and use the ruler tool. Go ahead and look to see where your water uptake is. Take a look at the moisture graph, see what depths you're pulling from. And after you have a rain or an irrigation event, use that ruler tool to see how much actually infiltrated into your soil versus your expectation. And the last thing I want to lead you with here, that having a good dealer can be a key to success here. I'd say that our customers who have a dealer who gives them good, timely recommendations and knows what they're doing and can guide them is going to be a grower who's going to stick using CropX, because they're the ones who are going to see the cost savings. They're going to see the ROI. They're going to see the yield growth. And also, you can make them better farmers. Any questions?
Ben, we've got a couple
Right.
in the queue here. We have some customers with rocky soil. Have you seen any probe damage during installation in rocky soils?
You know, with the V3, I would have said yes. That was very common. With the Vertex, I'm not really seeing that much. I think I can count. We've had thousands of installations. I think I can count on my hands the number of probes we've had actually damaged during install and extraction, which is something I couldn't say about the V3 back in the day. If you asked me that 2 years ago, I'd have a very different answer for you. But I'd say we're now in the 3rd year of using the Vertex, and they've gotten in and out there pretty well. I will say rocky soil, good case for doing a 4-inch offset. That's what I'd say there. And that's not necessarily for probe damage reasons. That's just for agronomic reasons.
Wonderful. I've got one more back here. And anyone can actually touch on this. Maybe Nick wants to add some too, but how much water is recommended when installing the V4 probe?
No, we always used to say with the old probe, we'd say pour water down there to force it to reach bowl point. I don't think I'd say that anymore. And I asked Nick here, would you agree with me? No water anymore? Would you agree with me?
Yeah, I'd say best practice is to maybe just use water as more of a lubricant on the bit rather than any sort of a softening device. There may be some extreme situations that would require larger amounts, but in best practice would be to just use only what you need, especially because some of those auto set points become a factor after that too.
Okay, following up on that question, curious about sensor depth. Comment is I do middle depth on the V4 drill auger. I do a 2-inch offset and have numerous issues with soil to sensor contact. So I think the question here is how far are you drilling down and just installation best practice is.
I'd always say one of the best things to do is look at that initial volumetric water content reading that you get in the notification after an installation. Because you've gone ahead, and we always suggest this when you're augering out that hole. You want to feel the soil at each depth. One, with our new installation feature where you go ahead and choose the wetness at each depth. If you're doing that, it helps you come up with the best answer there. But two, you have an idea of what that soil is, if it's sand, if it's silt, if it's clay, and what it can hold. So go ahead and just take a look at that first data point and make sure that it's giving you what you would expect there. Because if you're going ahead and you're installing something, especially if it's not sand, and you're seeing 5% volumetric water content, there's probably an issue there with soil contacts. You might have to go ahead and reinstall that.
Yeah, that's a great point. We didn't bring that up in some of the other sessions, but we did some practice examples last year at the conference. So like, I think the best way to put it is you're going to get the result immediately at install. And that's just what it's reading. Like the sensor is reading what is around it. Now, the question would be why? So you're going to get those first measurements. And if you look at them and go, one of these is not like the other, that's when you really need to start questioning yourself. Numbers that are in the low single digits, even high single digits, that's not reality for most soils. Like it can't be that dry. And so what is dry? Air, right? So that will start to indicate contact issues if you see some of those really low values.
And I can't emphasize enough how important it is to make sure we get it right on the installation. You don't want to have to go out to that field again until extraction.
Yeah, and I would say like maybe just like one slight update of like best practices is basically trying to match the depth of the hole to the depth of the sensor you're putting in. I mean, that's basically what we've always said. We do like 2024 was the first year for a little bit updated version of an auger that CropX launched. It's our standard now. So we have improved that, and obviously we'll have a new auger for the Cortex, which will be different than what you're using today for the V4. Anything else, Rebecca? Cool. Very good.
Thank you very much, everyone.